Okay. So in the previous classes, we have seen the Euler's method and the improved Euler's method. Today we are going to study another type of a Euler's method. This is a modified Euler's method, and this method is more accurate as compared to the simple Euler's method and the improved Euler's method. Okay, so as far as this modified Euler method is concerned, it is more or less similar to the your improved Euler's method, where you have a predicted equation for prediction, and where you have another equation for the correction. Okay, so usually the predicted equation. Okay, so let us start. So this y predicted. Okay, so I should put it in different way. I think we have used y0 and y1, right? Yeah, y0 and y1, right? So I'm saying y1 predicted can be calculated as y0 plus h into function of x0 and y0. Okay, so this we have seen in the Euler's method also in the previous lectures, if you see. So here the equation which is written in the red rectangle, this is a Euler's equation, that is y1 is nothing but y0 plus h into function of x0 and y0. Okay, so this is the predicted equation. So this is going to give you the predicted value of the point. Then in the improved Euler's method, we have seen a correction which we have to give to the predicted value. So you can see on your screen the one which is marked with red rectangle. This is the equation for the correction. Okay, so I'm going to write down this one. So we have y1 corrected will be something like y0 plus hy2 into, we have f of x0 y0 plus f of x1 and y1, where this f of x1 and y1 has to be taken from the predicted value. Okay, so if you remember in the improved Euler's method, this correction has to be applied only at the last. Okay, intermediate values we are not at all changing, only at the last we have to apply the corrections. Okay, so on the similar lines this method is also working, but in this method we have to apply the correction at every stage. Okay, so that we will see with the help of a numerical. Just give me a couple of minutes. Just give me a couple of minutes. Okay, student, so we'll resume now. So in the previous class, we have seen, or we have solved one numerical, that is dy by dx is nothing but x square plus y. So we are going to solve the same problem using this Euler's modified Euler's method. Okay, so we have numerical. So here we have some example. Okay, so we have dy by dx as x square plus y. Okay, and if you remember the boundary conditions which are given, the initial boundary conditions which are given, the y value was the y value we have to calculate for x value as 0.1. Okay, so the what is the value of y? Okay, for x value is equal to 0.1. Okay, so this is our problem, and the initial condition, that is initial point is at 0. So x0 and y0, they are nothing but 0 and 1. So here the initial point, so x0 is 0 and y0 is 1. Okay, is it okay, student? Have you understood the problem? Okay, shall I continue? Yes, shall I continue?
Yes, sir. Yes, sir.
Okay. Okay. So now you see, first of all, when we have to solve this particular problem, we have to give the intervals. Okay, and in the previous classes we have seen, if you give more number of intervals, you are going to get more accurate solution. Okay, so in this case, as far as this problem is concerned, I'm going to take only two intervals. Okay, you can take even one intervals also, but that is going to compromise the accuracy of the solution. So the number of intervals which I am taking over here, so n equals to 2. So now basically what we have right now, we have x, okay, x0 is 0, corresponding y0 is 1, and what we are interested in, what is the value of y when x value is 0.1. Okay, so in between I am going for two intervals, so I'll be needing one more value like this one. Okay, so it will be exactly half of the interval, so this will be 0.05. Let me call this as x2, let me call this as y2. I don't know its value and I don't know the value of y over here. So our aim over here is, first of all you need to find out the value of y1, and then we need to find out the value of y2. Okay, so now for this purpose we have to use the uh, modified Euler's method, and in the modified Euler's method, first of all I am going for the predicted equation. Okay, so predicted equation is y1 equals to y0 plus h into f of uh, plus h into f of x0 and y0. Okay, so our f of x and y is nothing but x square plus y. So if I want to calculate x0 and y0, so everything is going to become 0 0. So x0 initially, if you see this particular row, so we have, this is 0 square plus 1, so this is going to give me only 1.0. As far as h is concerned, so our h is basically the distance between two consecutive values of x. So your h value over here is 0.05, and y0 is already known to us, it is 1. So the predicted value of y1, so I'm going for y1 predicted as, this is 1 plus 0.05 times 1, so this is going to give me 1.05 value. Okay, so this is the predicted value, right? So now once the predicted value is calculated, we have to go for the correction. So I am going for the first correction, correction number 1. So if I go for first correction, so y1 corrected equals to, you will have something like y0 plus h by 2 into f of x0 y0 plus f of now x1 and y1. Okay, but now in this particular equation we know everything except f of x1 and y1. So f of x1 and y1 is nothing but x square plus y. In place of x, now you will have x1, y, in place of y you will have y1. Okay, so now here the value of x1, so if you see the second row, the value of x1 is 0.05. Okay, and the value of y1 just now we have calculated over here, that is 1.05. So basically this is 0.05 square plus 1.05. How much is this? Someone please tell me the answer.
1.0525.
0525.
Bus.
That's it. Okay, so now the y1 corrected. Okay, so y1 corrected will be now y0. Y0 is 1, h is 0.05 divided by 2 into f of x0 y0, just now we have calculated over here. So this is f of x0 y0, so this is nothing but 1.0 plus we have 1.0525. So how much is y1 corrected now?
1.0513.
1.0513. Okay, so now this is the first corrected value. So you see we have started with the predicted value, which is 1.05. Okay, and after correction the value was found to be 1.0513. Okay, but this is just the first correction. So now in the modified Euler's method you have to go for many number of correction unless and until you get the correct answer. So if this is correction 1, so I am going for this as C1. Okay, I'm going to put C1 over here. This is the correction 1. So let us go for second correction. Okay, second correction, so I'll say y1 corrected for the second time. We are going to use the same expression, that is y0 plus h by 2 into, now you have f of x0 and y0, but here now you will have f of x1 and y1, but this y1 will be the latest value, and presently the latest value is corrected first value. Okay, so out of which we don't know what is f of x1, y1 corrected for the first time. So this is x square plus y, so this will be x1, and y will be replaced with y corrected for the first time. So if you substitute the values, so this is 0.05 square, and here the value will be 1.0513. How much is this?
1.0538.
38. Okay, so if you substitute this, so y1 corrected for the second time, so this will be 1 plus 0.05 divided by 2, this is 1.0 plus 1.0538. Okay, so how much is y1 corrected for the second time?
1.0513.
0.55
0513.
13. Okay, is it okay, students? Someone please verify this.
Yes, sir.
Yes, sir,
Yes, sir.
correct.
Correct. So you see, if we see the values of y1 for the correction for the first time, which is this one, and here this is this one, both are same. Okay, so at this point we can stop, because even if you go for the third correction, the value will remain same. So we can assume that this is now the final answer. Okay, so what I'm going to do over here is, so earlier we are interested in finding out this value. Okay, so now the final answer will be something like 1.0513. Okay, so this is my final answer for the value of y1. The corresponding value of x1 will be 0.05. Okay, so this completes the first cycle where we have successfully calculated the value of y1 for x value as 0.05. Now let us start working on the what exactly is required, that is what is the value of y2 at x value as 0.2. So for this purpose we have to write the expression of y2 now. Okay, so your y2 can be calculated as y1 plus f of x1 y1. Okay, so if I say this is h multiplied by, and this should be predicted value. Okay, this should be a predicted value. So here this value y1 should be taken as the final answer, which is 1.0513. Okay, so y2 predicted, so here if you see the value of f of x1 y1 corrected, so this will be something like x1 square plus y, so this is 1 1, and this is the corrected answer. So this is 0.05 square plus 1.0513. This is the final answer, right? So as a result of this, ये कितना आ रहा है? कितना आ रहा है? This way I already calculated, right? That is 1.0538. Am I right?
Yes, sir.
So now let us calculate y2 predicted. So your y1, so the latest value of y1, that is the final value of y1, is nothing but 1.0513 plus h is 0.05 into 1.0538. How much is this y2 predicted?
1.1039.
Okay, so this is the predicted value. Okay, someone please cross check this answer.
Yes, sir. Right.
Okay, so this is the predicted answer. So now we have to go for corrections. Okay, so let us go for first correction. Okay, so the y2 corrected for the first time will be something like y1 plus h by 2 into f of x1 y1 plus f of x2 and y2, where y2 will be the latest value, that is the predicted value. Okay, so we don't have the actual value as of now as far as first correction is concerned, so we have to take the predicted value. Okay, so here we don't know what is f of x2 y2 predicted. So for this purpose, this is x square plus y. So this value will be x2, y value will be y2 predicted. Okay, so if you remember, the x2 value is 0.1, isn't it? So this value is 0.1 square, plus the predicted value of y2 is something like 1.1039. How much is this?
1.1139.
1.1139. So if you substitute these values over here, so y1, okay, so we have finalized the value of y1 earlier. So y1 value is 1.0513. Okay, 1.0513 plus 0.05 divided by 2. F of x1 y1 we have just now calculated over here. Okay, so this is something like 1.0538, and here also this is just now we have calculated 1.1139. So this y2 corrected for the first time, how much is this?
1.1054.
55 or 54?
54.
54. Okay, so this is the first correction value. So now I'm not sure whether this is correct or not. So for this purpose you have to apply the second correction. Okay, so for the second correction we are using a similar expression. So this is correction for the second time. So this is y1 plus h by 2 into f of x1 y1 plus f of x2, and this will be y2 will be the latest value. So y2 corrected for the first time. Okay, so from here I don't know the value of this, that is x2 y2 after the first correction. So this is x square plus y. So x will be replaced with x2, y will be replaced with y2 corrected for the first time. So this is 0.1 square, and this will be something like 1.1054. How much is this?
1.1154.
1154. Okay, so if you substitute these values, so this is something like 1.0513 plus 0.05 divided by 2. This is 1.0538, and this is 1.1154. How much is the value of y2 corrected for the second time?
1.1055.
Okay, 1.1055. Okay, but you see there is a small difference between these two values. So since there is a difference, so we have to go for one more correction. Okay, so this is correction number 3. So this is y2 correction for the third time. So this will be y1 plus h by 2 into f of x1 y1 plus f of x2 y2 corrected for the second time. So we don't know its value. So f x2 y2 corrected for the second time. So this is x square plus y. So this is x2 y2 corrected for the second time. So this is 0.1 square plus 1.1055. How much is this?
1.1155.
5?
5.
5. Okay, there is a minor difference. Okay, so this is 1.0513 plus this is 0.05 divided by 2. This is 1.0538 plus 1.1155. Okay, how much is the y2 corrected for the third time?
1.1055.
1.1055.
Okay, so now we see the two values, two consecutive values. So these are the matching values. Okay, so you can see this is the final answer now. So what I can do over here is I am basically interested in calculating this value. Okay, so the final answer will be your 1.1055. Okay, so like this you have to just keep on applying the corrections again and again, unless and until you get the correct answer. Okay, so this you have done only for two intervals. Okay, because remember, you see we have taken the n value as 2, that is from x0 equals to 0 to x equals to 0.1. We have taken one intermediate interval. So because of this one intermediate interval, you are getting the answers something like 1.1055. Okay, but if you take more number of intervals, like if you go for 3 or maybe 4 number of intervals, of course your calculations are going to get increased, but you will get even more accurate results. I'm not saying that this answer is wrong. This is correct answer, and even this is more accurate as compared to the Euler's method and improved Euler's method. So if you refer your notes earlier, so we have obtained the value of the corrected value. Here it was 1.1602. In the Euler's in the improved Euler's method, it is 1.16. As far as the actual answer is coming on to be 1.1055. No, sorry, yeah, 1.1055. So like this, if you see, this method is going to give you quite accurate result, because the Euler's method is going to give you 1.13. Okay, so this is also not correct, but the modified method is going to give you a very accurate result as compared to the other two methods. Okay, only thing is you just have to keep on applying corrections again and again, then only you will be getting the correct solution. Okay, so have you understood this method? Are there any queries? Yes, students, are there any queries?
Understood, sir.
Sorry.
Understood, sir.
Okay, fine. So we will stop here now. In the next class, I am going to cover the programming part of all three methods.